Welcome to the So What video podcast, inaugural first episode. I am your host, Benny Dillon. The goal of this podcast for me was to help explain and answer that simple yet very elusive question of so what when it comes to technology topics and GovCon topics. We hear about a lot of different things in our world. We talk about a lot of different things in our world, and it's very hard to get to that real so what question or answer. So the goal is, again, every week I'll be joined by someone a lot smarter than me to help me answer that question. And please, leave us some comments, give us some suggestions. Feedback is the most important part of what we do. So today, my guest is Mr. John Partee. John was kind and brave enough, I guess, to volunteer for this first episode. John, if you would take a minute and just tell us a little bit about yourself, your background, kind of how you got here, and then we'll get going.
Yeah, so John Partee, I've got a master's in data science, bachelor's in computer science. Spent 8 years in the Air Force. So, we're talking ML, AI stuff today, so that's right in my wheelhouse because I just finished that master's almost a year ago.
What'd you do in the Air Force?
I was all over the place. Network engineering for my first 4 years, RF, satellite systems, all sorts of power, HVAC, everything for another 2, and then network engineering, kind of DevOps-y type stuff towards the end. So
very cool. Well,
plugged into a wall, I worked on it.
That's very cool. I appreciate your time. I know it's always nerve-wracking to be the first one to do anything, so I appreciate it. So today, as I mentioned the format, right? I want to ask you a couple of questions, and it's kind of leading up to that idea of so what. And for today, the topic for us is machine learning. Mm-hmm. It's machine learning or ML. Oftentimes I see it intermingled with AI. And I feel like someone on our team said, just sprinkle some machine learning or AI on it and talk to the customers or talk to your team about it. I really wanted to get your help, right? Because this is what you studied and you've been studying is, in simple terms, what is machine learning?
Sure. Machine learning is statistics into video.
Done. That's it. As simple as that. So statistics. So
sincerely, yes. So even some of the crazier models that we hear about these days, right? Deep neural networks and all this and doing computer vision on pictures and videos and everything else. It's just statistics applied across a big network. So we stack a bunch of these models together, do the same thing.
So it's not new, right? It's not brand new. It's not like something someone just invented in 2012, because that's when we started hearing about it.
So most of the really interesting machine learning work that's being done today is from papers written in the 50s. The big deal is that we have computing capabilities to actually take advantage of this stuff today.
Do you think machine learning was reintroduced or re-energized, number one, because of the compute power we have, but also just the vast amount of data, both in simple data like text and or paper, but now video and images, and how many trillions of images are being created a day? Do you think that's also a part of kind of the resurgence of machine learning, in your opinion?
You could say that. I think it's more to do with just the raw compute power, right? GPUs have thousands of cores that allow us to run these massive neural networks really efficiently. And that's the big difference from 50 years ago.
So now we have the ability to do or realize that theory.
Yep, exactly. No doubt the big data helps.
Got it. So again, one of the challenges I see in our space, right, in government contracting and technology in general, is there's lots of noise in the market, right? You have people that throw out words and terms all the time without any real context. So one of those terms I hear all the time intermingled with machine learning, I see you laughing. So it's people will say AI ML or ML AI, and they may not even know why they're saying both terms. Right. So in your words, how is machine learning different or a different thing altogether than AI, or machine learning?
So I'm laughing because everybody always says ML AI as though it's just a thing like you buy an automation or buy a network switch, right?
Right.
So AI is kind of a big blanket umbrella term in my mind. AI is the idea of building software to solve human-centric problems or problems that would be solved by humans previously. ML is a small part of that allows us to kind of figure out the stats side of that, right? So if we need to be able to predict assembly line failure rates or something, ML is what allows us to look at that widget that came off the assembly line and say, oh, that one's broken for sure. AI is what is kind of the bigger ecosystem that would take that little bit of ML insight and yank that guy off the assembly line.
Is it also fair to say that machine learning is a part of the building block or a foundational block to get to AI or artificial intelligence, where it takes in lots of different inputs to make a decision or to artificially understand or be artificially intelligent. So would you say that's fair?
Absolutely. Well, with the caveat that there is a lot that you can do by hand. So, if you're standing up a rudimentary software pipeline to solve a problem that we would call an AI problem, right? You could do that with if statements, if else, like if this widget is turned the wrong way, pull it off the assembly line. But you can only get so far with that, right? ML allows us to extrapolate what we've seen, what we've kind of planned for already a little bit further out.
So they do work hand in hand at a point to make to help it scale, to help it get to that next level.
Sure.
They're not the same thing. They work together. Do you see that in our industry, again, in the government world or the government contracting world, in IT, that people tend to overlap or interlace these, or intermingle these terms because they have a lack of understanding, or because it's just the easy marketing thing to do right now?
That's an interesting question. I think it's more of an easy thing to do, but not from a marketing perspective. Usually when people say MLAI, they say it because it's somebody else's problem, right?
Mm.
So like if we're rolling out Splunk and they say, oh, can this do MLAI? Sure, yeah, Splunk can do that. Yeah, I mean, MLAI is usually a term for somebody else does it. It's fine.
So I don't have to worry about it. So I can just use the nice buzzwords that are out there, let you have the
Sure.
issue. You had to work through it. Got it.
It's like big data. Yeah.
Yeah, big data is similar. And we hear this a lot, right? We hear this, and that's the whole bottom line of why we're doing this video podcast is there's so much noise, there's so much out there in terms of what people think is true or what they want to think is true and what industry pushes down on them. By the way, I think industry, us, have a lot to do with the misinformation of hey, no, it's just it's ML, it's AI, don't worry about it. I think that's something that, again, from an education standpoint, we'd need to do a better job of. From a machine learning or AI example or in action, I know you gave a couple of examples. Can you take us through a little bit more in detail of, give me a little bit more of a machine learning type of example? Take it from soup to nuts, right? This is what it would do. This is why it's important. And then kind of on the other side of that, say, hey, this is what an AI type of example would be. Because I think that's important. People always learn with stories and use cases.
Yeah, so let's take kind of a step back, right? So AI, first of all, in my context, at least in my mind, in my world, is going to be just applied ML. So we're taking ML insights, ML predictions, and doing something with them. That's AI covered. Circling back to ML, there's two kind of major spaces where we work in with ML, right? So there's prediction and classification. The difference there, right? So like if we're predicting stock prices, we expect that this is going to be, up $15 in a month or two. That's a prediction task. If we're just going to guess whether or not that's going up or down, that's a classification task. So it has a Boolean yes or no, or yes, no, maybe type answer. Those two are very specific, right? There's only so many cases where those two ideas are really useful. There's more that you can do under the broad umbrella of ML, but those are kind of the big ones. Excel has a great use case where they're using neural networks, and this is kind of an AI use case. So they're using a neural network to predict whether or not what they're looking at is a sandwich in a picture, right? So they're stacking a bunch of layers of neural networks that are figuring out things like, hey, is this a sandwich? Could it be a sandwich? Yes or no, is this a sandwich? Okay, it's a sandwich. Now let's track this sandwich across the screen. So then we further extrapolate that out to, we're going to track these 10 sandwiches sitting underneath this heating lamp at a customer, because they can only be on or underneath the heaters for like 2 or 3 hours. At that point, to get to the AI side of this, we send the folks sitting in the restaurant an alert whenever a sandwich is sitting there for more than 3 hours. They can pull it out and throw it away, right? So that's prediction. Could this be a sandwich? Maybe. Classification, yes or no, it's a sandwich. And then AI, right, is that deployment where, hey, operator guy, that sandwich is gross, pull it off.
So to your point, AI and machine learning differ in the fact that machine learning gives you that statistic of whether it is or it isn't, classifying whether it is or isn't, and then AI kind of takes that higher level role that you talked about to actually now make a decision based on that information.
I think that's fair. Yeah.
So you know what's coming next, right? The infamous question. So in this world that we live in, with the amount of data that we have, the different things that we're being tasked to do, automatic driving cars, this whole kind of next generation, what's the so what of machine learning? Why is it even something that we should think about, care about, know about, right? Give me that so what, if you don't mind.
I mean, the big thing is machine learning allows us to do statistics at scale that have never been possible before, right? So self-driving cars, we can predict whether that blob that our camera sees is a person or not and slam on the brakes if it is, which again, right, the ML's looking for that person, says, could that be a person? Maybe, let's check it out. Classification, yes or no, is that a person? Yes, that's a person. Oh my God, the AI kicks in, slams on the brake. It's massively transformative because it allows us to work with stuff that we've never seen before.
Do you think, in the current world of COVID and these vaccines that were developed so quickly, that machine learning and things like that, right, being able to apply statistics to huge volumes of data and huge data sets helped us get there faster this time?
I don't think so, just because mRNA vaccines have been in process for the last 50 years and they're fascinating and they're totally own thing. Where it is interesting is that kind of big data public health perspective informs some of the decisions that we made, right? So like, do mask mandates work, yes or no? Does mask compliance predict the degree that we have surges and that kind of thing? Hugely helpful.
Right.
And again, that's boring statistics, but that's ML. Stats is just ML. Same thing.
So, John, for all the kids listening to this, we're going to tell them to pay attention to statistics class, because if they want to grow up to be machine learning engineers like yourself, they've got to know and pay attention to statistics. So, bottom line,
Yeah.
so what, folks, is that's machine learning at its core. It's statistics. It's being able to take large volumes of data, large data sets, and apply statistics to it. Machine learning is just the nice, cool current buzzword that we're using. As a wrap, that's what I want to get to with these episodes, right? Want to be able to get to the bottom line of what is machine learning? Why should we care about it? And so, real quick, for the folks who watch this, who consume this, we'd love some feedback. Is this too much info? Is this not enough info? What do you want to know more about? We'd love to interact with you and get some feedback. And with that, John, I appreciate your time, brother. Thank you. And again, kids and parents, tell your kids if they want to grow up to be machine learning engineers, they better know statistics. They better learn their statistics. So,
Yep,
John,
it helps.
thank you so much. Hopefully, you'll join us again for our next podcast.
Absolutely.
Thanks, man.